Good day, everyone. Welcome to the episode 1 of CHM 111. And for this very class, we'll be working on the history of the periodic table. In terms of classifying the elements in the periodic table, a lot of scientists have actually tried, but most cases we always refer to ANTIONE, LAURENT, LAVIOSIER, and the sixth person here, which is the Dmitry Ivanovich Mendeleev. But the truth is that from ANTIONE, LAURENT, LAVIOSIER to Dmitry Ivanovich Mendeleev, there are a lot of scientists that contributed to the classification of elements in the periodic table. So for this very video, we are going to walk through their contribution, what they contributed to the arrangement of the periodic table, which of them is very, very prominent to the periodic table we are using now. Now, at the end of the whole classification, the current periodic table we are using is not even from Dmitry Ivanovich Mendeleev, but in our SSC, which is secondary school textbook, we are told that the current periodic table is being constructed by Dmitry Ivanovich Mendeleev. But the truth is that it was constructed by Moseley, who proposed the modern periodic law. So let's start with the first scientist that classified the element in the periodic table, which is ANTIONE Laurent Lavoisier. He classified the element into, or he listed simple substances that cannot be decomposed, list of compounds that we can't decompose, and he classified them into three groups, which is we have the metals, we have the acidic oxide, and the last group here we have the earthy salt. So, which is the whole periodic table we have, it was classified into these three groups according to ANTIONE Laurent Lavoisier, who is the first person that classified the element in the periodic table. But then in our secondary school test, we were told that he classified the element into two, which is metals and nonmetals. But here he classified the element into three. We have metals, acidic oxide, and earthy salt. But there are some elements that also fall into these three categories. So this was how his periodic table was. This was the shortcoming of his periodic table. They led to the second man here, which is Johann Wolfgang Duberener, who classified the element into three groups. I mean, these particular groups of elements, they have the same chemical properties. So what this guy does was, he will look for three different elements that have the same physical properties. Then he will pick the first one, pick the third one. He will write 1 plus 3 divided by 2 to give us the middle element. So this was his periodic table, and they call it triad. So the person that postulated the existence of triad is called Johann Wolfgang Duberener, and the scientist that classified the element into metals, acidic oxide, and earthy salt is called ANTIONE Laurent Lavoisier. Let me give you an example quickly. We have lithium, we have potassium. Lithium is 7, potassium is 39. So what this guy does is, for us to get the middle element, he writes 39 plus 7 divided by 2. 39 plus 7 is going to give us 46. 46 divided by 2 is going to give us 23. So the question is, which element in the periodic table has the atomic mass of 23? So the answer is what? Is sodium. So lithium, sodium, and potassium, they all belong to the same group in the periodic table. So this was Johann Wolfgang Duberener classification. He classified the elements using triad. So triad simply means a group of three elements that have the same chemical property. So we pick the first element, you pick the third element, we divide it by 2 to give us the second element. The third guy that classified the element in the periodic table is de Chantois, and this was his classification gained no support because he uses the helix structure. He plotted the element in the periodic table in a cylinder following the angle of 45 degrees. So that means if you want to write hydrogen, your hydrogen will be here, your helium will be here, your lithium will be here, your beryllium will be here, your boron will be here. This was how he classified the whole element in the periodic table. So using a helix structure, which is a cylinder structure of 45 degrees. The angle he used there was 45 degrees. Then this whole classification is called the telluric concept. The telluric concept. So that was the Chantois periodic table. So the atomic weight of an element was plotted along these helix trace of 45 degrees in a cylinder. So this was how the Chacointois classify the periodic table. So the fourth one we have there is John Leland. He realized that the physiochemical property of element, they have a recurrence of 7 interval, which is at the end of 1, 2, 3, 4, 5, 6, 7. Whenever you get to 7, we are going to come back to 1 again. So they recur at 7 interval. So because of that, he classified the element using do, re, mi, fa, sol, la, ti. Okay, let me write it so well. Here is do, re, mi, fa, sol, la, ti. The last one is do. Now, he believed that do is the same thing, so he removed the last do. So he classified the element into 7 recurring group or into 7 group. So here will be a hydrogen, here will be lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Now, you are asking, what happened to helium? What happened to neon? As at that time, the halogen have not been discovered. So he classified the elements into 7 groups. And he believed that at the end of 7, we are going to come back to group 1 again, to group 2, to group 3, to group 4, group 5, group 6. And this is something related to the periodic table we are using now. So the person that started the periodic table we are using now is actually John Leland, who proposed the law of octave, the octave law. So John Leland was the one that proposed the law of octave, and he believed that the element, the chemical properties of element, they have a recurrence of 7 intervals. So at the end of 7, we are going to come back to 1 again. And he believed hydrogen and helium, they have the same chemical property. Beryllium and the next element here, which is magnesium, they have the same chemical property. So this was his classification. So that will take us to the next guy, which is Julius Lothar. According to Julius Lothar, he classified the element using a physical property called volume. The physical property used in classification of the element is called volume. He plotted a graph of atomic volume against the relative atomic mass. So his graph was, so he plotted the graph of atomic volume against the relative atomic mass. So let's say here is atomic volume, then here is relative atomic mass. This was the plot of his graph. So that means the periodic table we are using are supposed to be hydrogen will be here, helium will be here, lithium will be here, beryllium will be here, boron, carbon, nitrogen. This was according to Julius Lothar, and he was the one that proposed the periodic law. So in the periodic table, or in the history of the periodic table, we have 2 laws. We have the periodic law and we have the modern periodic law. Now, Dimitri Mendeleev didn't propose the periodic law, not even the modern periodic law. So the periodic law was proposed by Julius Lothar, while the modern periodic law was proposed by Henry Moseley, which is a physicist. So what was the contribution of Dimitri Mendeleev? So according to Dimitri Mendeleev, he classified the elements using atomic weight, and he followed the same pattern as John Leland. John Leland was the one that classified the element into 7 groups. So what Dimitri Mendeleev does, he classified the elements using the atomic weight. So if hydrogen has a lower atomic weight, hydrogen will be in group 1 compared to the next element here. So that's to say the atomic weight of beryllium is higher than that of lithium, boron is higher than that of beryllium, carbon is higher than that of boron, nitrogen is higher than that of carbon, oxygen is higher than that of nitrogen, fluorine is higher than that of what? Of oxygen. So this was his classification of the periodic table. That is for Dmitry Ivanovich Mendeleev. And he also opined that the physiochemical properties of elements vary periodically in order of their increasing atomic weight. So he believed that the atomic weight of the elements, the physical and chemical properties of the elements, it increases in order of their increasing atomic weight. So this was Dmitry Mendeleev's classification of the periodic table. Then, according to Henry Moseley, which is H.E.G. Moseley, after the discovery of proton, and we believe that proton number of an element is the same thing as the atomic number of that same element. So when the atomic number of element was discovered, that is when X-ray was used to discover the proton number of an element, he said we cannot classify the element using atomic weight. That is best we classify the element using proton number or atomic number. So he was the one that proposed the modern periodic law. So like what I said earlier, the periodic law states that the physiochemical parts of elements, the physical and chemical parts of elements, they vary periodically in order of their increasing atomic weight. So after the discovery of proton, he replaced the atomic weight by atomic number or by proton number. So he said the physical-chemical parts of elements, which is the physical and chemical parts of elements, varies periodically in order of their increasing atomic number or in order of their increasing proton number. That was after Henry Moseley have discovered what? X-ray. The first thing, ANTIONE Laurent Lavoisier classified the elements into three. We have the metals, we have the acidic oxide, and we have the what? The earthy salt. For Johann Wolfgang Dobereiner, he classified the elements using triad. These are three groups of elements or a group of three elements that have the same chemical property. Then for the Charcontois, he was the one that used the Helix trace of 45 degree, a Helix trace of 45 degree, and he plotted the atomic weight of an element along the Helix trace of 45 degrees. So what about John Lennard's classification? He was one that proposed the law of octave. A question will pop to your mind. That's octave, OCT, simply means 8. So why are we using 7? I've explained that already. We have do, re, mi, fa, sol, la, ti. The last one here is what? Is do. So if you count 1, 2, 3, 4, 5, 6, 7, 8. He believed that do and do is the same thing. So he worked with one. But remember, by then, the noble gases have not been discovered. So he only work with group of 7 elements. Then the next one we have here is Julius Lammeyer. He plotted a graph of atomic volume against the relative atomic mass. And his classification was based on a physical property called what? Volume. Then for the sixth guy, which is Dmitry Ivanovich Mendeleev, he was the one that classified the element based on the chemical behavior, based on their chemical behavior, and he worked with the atomic weight of that element. Then he also believed that Julius Lammeyer classification of the periodic table are not truly correct, but the law that was proposed by Julius Lammeyer is very, very correct, which is the periodic law that the physicochemical parts of element varies periodically in order of their atomic weight, that it is correct according to Dmitry Mendeleev. Then he worked with John Lennard periodic table, who proposed the law of octave. Then after a while, when X-ray was discovered, then H.E.J. Moseley, he was the one that now classified the elements, which is the modern periodic table we are using now. He was the one that started the modern periodic table we are using currently by the discovery of proton number, which is also the same thing as the atomic number of the element. In summary, the list of simple substances that cannot be decomposed on analysis was classified by Antoine Laurent Lavoisier, who classified the elements into three groups: metals, acidic oxide, and earthy salts. Then, after a while, Johann Wolfgang Dobereiner classified the elements using triad, which is a group of three elements that have the same chemical property. Then he moves to the next guy, which is the Charcontois, who proposed the telluric helix concept, and his periodic table gained no support because of the way he plotted the whole stuff. And there's no way you can even draw that periodic table. Then the next guy here, which is John Lennard, who proposed the law of octave, that elements will occur in 7 interval. Then followed by Julius Lammeyer, who proposed the periodic law. He plotted a graph of atomic volume against the relative atomic mass of the element, and his classification is based on a physical property called volume. Then the sixth guy, which is Dmitry Ivanovich Mendeleev, he classified the element based on chemical behavior, and he also supported the periodic law, but worked with John Lennard periodic table. Then the last guy, which is Henry Moseley, after the discovery of X-ray, he proposed that there is no need for us to be working with atomic volume, that it is best we work with proton number of an element, which is the same thing as the atomic number of that element. So quickly, I want to ask you a question. Among all these, which is Lammeyer, Dmitry Mendeleev, we have Dobereiner, the Charcontois, all of them, which of the following gain no support? I repeat, which of the following periodic table gain no support? Let's assume that number 1 is option A, here is option B, option C, option D, option E, option F, and option G. So which of the following classification of the periodic table gain no support? That's question 1. Then question 2, among all these, Which one do you feel did the major work? But please take note, the founder of the periodic table is Anthony Laurent Lavoisier, and the father, there's a between founder and the father. Founder is the person that started the whole work, so is Anthony Laurent Lavoisier, but the father of the periodic table, the person that is considered the father of the periodic table, is Dimitri Ivanovich Mendeleev. And one of the reasons why he's classified or is considered as the father of the periodic table was he did a lot of prediction. He said, as so year, a particular element will be discovered and it's going to fit in into so group in the periodic table, into so period in the periodic table. So Attila Laurent Lavoisier is the father, and Dmitry Ivanovich Mendeleev is the founder of the periodic table. So the second question is, among all, who do you think did a major work in the classification of the periodic table? Is it option A or is it option D? Please drop that answer in the comment section. See you in our next episode. Goodbye.